Hello everyone. In this session, we are going to see about CPU scheduling algorithm. Myself, N. Moahana Priya, working as assistant professor in the Department of Artificial Intelligence, Madanapalle Institute of Technology and Science. The flow of presentation is first we will start from introduction, scheduling types, CPU scheduling algorithm, FCFS algorithm, problems with the solutions, advantages and disadvantages of FCFS scheduling algorithm, summary and reference. First, we will see about what is meant by CPU scheduling. So, CPU scheduling is one of the fundamental operations of operating system that scheduling which is deals upon deciding which process we have to select from ready queue. In ready queue, many processes are waiting for execution by the CPU. From that, only one process will be selected by scheduling algorithm. That process will be assigned for CPU for execution. So the scheduling algorithm which helps to manage execution of multiple tasks on computer. Next, we will see about types of scheduling. There are two different broad category of scheduling algorithm is there. One is preemptive scheduling, another one is non-preemptive scheduling. In preemptive scheduling, during execution, our process interrupted by another process which having the higher priority. The best example is round robin scheduler. Second type is non-preemptive scheduling, in which the process during execution it never be interrupted. Once the process start to execute, that will be continue to execution until it terminates, or otherwise the burst time is over. In between during execution, any higher priority process are arrived for execution means it won't allow. But in preemptive scheduling, during execution, any higher priority process are arrived means currently running process temporarily it is suspended and higher priority process will be assigned for execution. For non-preemptive scheduling, the best example is first come first service scheduling algorithm. Okay, next different types of scheduling algorithm we are going to see. First one, first come first served scheduling. Second one, shortest job first scheduling. Next, priority scheduling, round robin scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. Let's see the first one, first come, first served scheduling. Already I said that first come, first served scheduling algorithm is non-preemptive scheduling. Here the process are arrived and they are placed in a ready queue. The order in which arrived, it is a principle they are following for to take the only one process from the ready queue and assign to the CPU. This FCFS scheduling is very simple scheduling and it is very easy to implement. Here they are using first in first out data structure, queue data structure they are using. So that's why it's very easy to implement. But the waiting time for FCFS scheduling policy is very more large. So it is not much efficient, but it is very simple to implement. Now we will see the problem, then we can understand. The first problem, we will take the three process. The name of the process is consider P1, P2, P3. All three processes are arrived at the same time. Let's consider that is a zero time. So the processes are placed into the ready queue in order P2, P3 and P1. P2, P3 and P1. So in ready queue, process P2, P3, P1, all three processes are reside. So now you have to take only one process from the ready queue that will be selected by first come first service scheduling algorithm. The order in which arrived the process will be selected. Now P2 is available in the ready queue. From that it will be selected and it will be scheduled to execution by the CPU. For the execution, we will represent using the Gantt chart. The Gantt chart which is used for to represent starting time and finishing time of each and every process participating for the execution. So now the P2 process will be executed. Now the P2 process will be admitted into the CPU. At that time the time is 0. Now P2 burst time is 4 unit time. That's why next 4 unit time will be executed by the P2. After completion of P2, the second process available in ready queue is P3. That's why the P3 will be admitted into CPU for next 4 minutes. So 4 plus 4, 8 minutes. At 8th minute, the process P3 will be completed. After completion of P3, now the process P1 will be admitted into the CPU. When P1 is admitted, the time is 8. The P1 burst time is 25 milliseconds. So next 25 milliseconds, the P2 will be executed. Later it will be leave from the CPU. So the waiting time of each and every process, now you have to find out from the Gantt chart. Now the process P1 waiting time is up to 8 minutes. The process P1 is wait. Why? Because P2 and P3 both process completion. After completion only the process P1 will start executed. That's why the waiting time of P1 is 8 minutes. P2 process waiting time is 0. Why? Because immediately it will be admitted into the CPU when it's arrived. So the waiting time of P2 is 0. Next one, waiting time of P3 is 4. Why? Because P3 will be start after completion of P2 process. That's why the waiting time is 4. So the next average waiting time he had to calculate by sum up all the waiting times, and he had to divide the sum by number of process. Here 3 processes there. That's why the average waiting time is 8 plus 0 plus 4 divided by 3. So now we will get 4 milliseconds. This is the average waiting time of the process using the FCFS scheduling algorithm. So next we will see about the same problem, but the order of arriving the process is changed. Suppose our process are arrived like P1, P2, P3. Assumes that our process are arrived in order P1, P2, P3. P1 burst time is 25, P2 burst time is 4, P3 burst time is 4. So now here in ready queue, 3 processes are available, P1, P2, P3. From that only one process will be selected for execution. In queue, the first process is P1. That's why P1 will be selected for execution among these 3 processes. That's why P1 admitted into the CPU at 0 unit time, and it continued to execution next 25 minutes. Why? Because its burst time is 25. So after 25th minutes milliseconds, the process P1 completes its execution and leave the CPU. P2 now start to execute, and next 4 minutes it utilizes the CPU for execution. P3 will be start from 29 milliseconds onwards, and execution will be continue for next 4 minutes. So later you have to find your waiting time of each and every process. For process P1, the waiting time is 0 because P1 is the first process admitted into the CPU for execution. Next process P2 will start execute from 25 milliseconds onwards. That's why the waiting time of P2 is 25. Next one, P3 process will be start from 29 milliseconds onwards. That's why P3 will wait up to 29 milliseconds. Next, we have to find the average waiting time. Sum of all the waiting times divided by 3, we will get the average. So now you will get average 18 milliseconds. But both the problem 1 and problem 2, same problem only, but order they arrived, it's changed. That's why the waiting time for the second problem is 18 milliseconds, but for the previous problem, the waiting time is 4 milliseconds. So here, what we had to conclude means any process having the largest burst time will be arrived first, and smaller burst time process are arrived later, means the average waiting time of the process is very high. Why? Because here larger process which takes a more time for the completion, the smaller burst time process need to wait. That's why the average waiting time is more. This effect we called as a convoy effect, which means that when higher burst time process are arrived before that process with the smallest burst time, then the smaller burst time process need to wait to complete the larger burst time process and release the CPU. Next we will see about the third problem. Here the different process will be there, P1, P2, P3, P4 and P5. All these processes are arrived at the different time, different arrival time. Previous two problems, all the processes are arrived at the same time. That's why the arrival time is 0. But here all the processes are arrived at different time. So now process P1 arrived at 5. P2 arrived at 7 unit time, P3 arrived at 0 unit time, P4 arrived at 7 unit time, P5 arrived at 6 unit time. The burst time of the process is given here. P1 burst time 6, P2 burst time 5, P3 burst time 4, P4 burst time 3, P5 burst time is 6. Now you have to calculate average waiting time and average turnaround time using FCFS scheduling algorithm. So first you have to write in a ready queue. In ready queue, all the processes are arrived. Here, while arriving, the time you had to very important. Arrival time is very important. Here, the first process P3 is arrived first. That arrival time is 0. That's why in ready queue, P3 had to place first. Next minute, that fifth minute, the process P1 is arrived. That's why in ready queue, second process become a P1. The next process P5 arrived at 6 unit time. That's why P5 in the third place. P2 and P4 arrived at same arrival time 7. So that's why it kept on last. In Gantt chart, now you have to represent how the process are scheduled. Here starting time and finishing time of your process you have to represent. P3 is the first process. That process will be admitted immediately at 0 minutes. The burst time of the process P3 is 4. That's why the process execution will be completed at next 4 minutes. Next fourth minute, there is no process in the ready queue. So at the time, your CPU is ideal. Your CPU is ideal. Fifth minutes only, process P1 is arrived. So at the fifth minute, process P1 is arrived. So immediately P1 will be admitted for execution. P1 burst time is 6. That's why 5 plus 6, 11th minute, it will be completely execution is over and come out from the CPU. Next process P5 will be admitted at 11th minutes and it continue to execution 5 burst time. Your execution time is 5. That's why next 5 minutes will be executed. So next P2 process will be admitted. Here P2 and P4 both having same arrival time. When the tie is occur, we have to break the tie by smaller ID process we had to select. So P2 and P4, these are the two process arrived at the same arrival time 7. So to break the tie, we had to choose the smallest ID. So the process P2 we consider as the smallest ID. So P2 will be selected for execution. After that, P4 will be selected for execution by the CPU. So in your Gantt chart, P3 admitted 0 unit time, finished at 4 unit time. 4 to 5, there is no process are arrived. That's why it is ideal. Fifth minute, the process P1 will be admitted and it finish next 6 minutes. So 11th minute, it leaves the CPU. At 11th minute, process P5 will be admitted where it will be execute next 5 minutes. So at 16th minute, process P5 will leave from the CPU. Process P2 will be admitted from 6th minute onwards and it continue to execution next 5 milliseconds. P2 will be completed at 21 milliseconds and P4 will start from 21st minutes onwards. and it will be executed for next 3 minutes. So 21 plus 3, 24 milliseconds it will be take to complete. At 24th minute, P4 completely come out from the CPU. So for this process are executed. Next we are going to see about calculate waiting time and turnaround time. To calculate the waiting time, we have to subtract the arrival time from starting time. The starting time means the time in which your process will be submitted into the CPU. That is called as a start time. So to calculate the waiting time of each and every process, now we will see about that process P1. P1, where is the P1? P1 will be start at 5 unit time. Its arrival time, P1 arrival time is 5. So start time is 5 and arrival time is 5. 5 minus 5, we will get 0. That is the waiting time of process P1. Next, for process P2, the starting time is 16. See here 16 is there. Starting time of P2 is 16. The arrival time is 7. So 16 minus 7, we will get 9. Next, for process P3, P3 starting time is 0 and its arrival time also 0. That's why 0 minus 0, we will get 0. For process P4, the starting time is 21 and its arrival time is 7. So we will get 21 minus 7, 12. For process P5, the starting time is 11, arrival time is 6. So 11 minus 6, we will get 5. So this is the waiting time of corresponding process. So process P1 wait only 0 milliseconds. So it is not wait directly, it is admitted into the CPU for execution. P2 wait up to 9 milliseconds, 9 unit of time to execution start. P3 will be wait 0 milliseconds only. When directly P3 came, immediately it will be admitted. So that's why there is no waiting time. For process P4, it waits 12 milliseconds. For P5, it waits for 5 milliseconds. So this is the average waiting time of corresponding process. Next, we had to calculate turnaround time. The turnaround time we had to calculate, simply we will sum up waiting time and burst time. So when we add burst time and waiting time, we will get the turnaround time. Already we have calculated waiting time. So in that waiting time, just simply had to add the burst time. Burst time already given in the problem. So waiting time of process P1 is 0. Its burst time is 6. 0 plus 6, 6. Then waiting time of process P2 is 9 and its burst time is 5. So 9 plus 5, 14. Then waiting time of process P3 is 0 and its burst time is 4. So 0 plus 4, 4. Next, waiting time of process P4 is 12. Burst time is 3. So 12 plus 3, 15. Next, waiting time of P5 is 5. Its burst time is 5. So 5 plus 5, 10. So this is a turnaround time of each and every process. Next, we had to calculate the average waiting time and turnaround time. Waiting time we had to calculate by sum of all the process waiting time, that is 0 plus 9 plus 0 plus 12 plus 5, whole thing sum up and divide by number of process. Here the number of process is 5. That's why you will divide by number of process 5. So now you will get waiting time is 5.2 unit. Next, average waiting time we had to calculate by sum up all the process where turnaround time divided by number of process. The turnaround time for the P1 is 6, P2 is 14, P3 is 4, P4 is 15, P5 is 10. So sum up all and we had to divide by 5 and we will get 9.8 unit time. Next, we will see advantages and disadvantages. The FCFS scheduling algorithm is very simple and it is very easy to implement. Why? Because you are using a data structure, queue data structure. And the drawbacks, there is no preemptions we are following. That's why in between, during execution, we can't remove any process from the CPU. That is one drawback. And also that another drawback, because of the non-preemptions, lower burst time process need to wait more time when currently running process having the burst time is more. Then at that time, smallest burst time process need to wait very long period of time. That is we called as a convoy effect. Convoy effect. And also that there is a possibility of starvation is occur. And also average time of the process is very high. Average time of the process is very high because of this very simplicity and easy to implementation, but efficiency is very less for FCFS scheduling algorithm. Today in this session we are discussed about definition about the CPA scheduling, types of scheduling, different scheduling algorithm, and sample problem with the solutions, and merits and demerits of FCFS scheduling algorithm. I thank the author Silbert Carr's book name Operating System Concept Essential 9th edition, because I refer some of the concept, some definitions I found from this book. I thank the author. If you are having any queries regarding in the session, you can leave your queries in this link. Thank you all.